Okay, so we're going to look at first example, looking at a second order differential equation and finding the symmetries. So we apply the infinitesimal generator, and I've shown you those expansions. So here we have xi times 0, eta times 0, first prolongation times 0, and then the second prolongation times 1. And we expand. And so Lie's invariance criteria tells me that this will be 0 when my function, and so my function is, that's my f, right? So when that is 0, which means that in the expansion that I have, that becomes 0, which then kind of simplifies it slightly. And that's what we end up with. So here we have what we're going to start working with. So we get from here what we call our determining equations, or our monomials. And the way we find them is we look at the coefficients of the powers of y prime. So the first one we have came from y prime to the power 0. The second one is y prime to the power 1. The third one is y prime to the power 2. And our last one came from y prime to the power 3. So that's kind of where these determining equations came from. And now we're going to solve them, or we're going to use them to then help us eventually get to our definitions for eta and xi. So from equation 4, we can integrate first in terms of y, which then tells us that we get a function in x. So a of x is just some function in x. And then we integrate again with respect to y. And now we have some kind of definition to my function, or to my xi. So I have some kind of definition. It's not clear yet. It's not complete yet because it's all in terms of a of x, b of x, but I have a starting point. So now from this equation 5 that I have, I can now determine, so I look up at my equations 1 through 3, and I look at which derivatives of xi will I need, and I find those, and I leave that then here. Those are my derivatives of xi that I'm going to maybe need to use. Now we look at equation 3. And from equation 3, we make some substitutions based on what I found here. And we carry on with that. So we start, there's my equation 3. We make our substitution. And now we're going to start integrate with respect to y, giving us equation. And then when we integrate that, we're going to integrate again. And so now I have in equation 11 some form of eta, except again, I still have to figure out what a of x, b of x, c of x, and d of x are. So we're going to carry on now. And again, I look up at the other two equations. So now I've got equation 1 and 2 that I'm looking at. And I use that to then take equation 10 and differentiate with respect to x. I also take equation 11 and differentiate twice, because these are values that I'm going to be needing in equations 1 and 2. So then we take equation 2, we make some substitutions, so that now instead of just having eta and xi, now everything's in terms of some form of a of x, b of x, c of x. We manipulate and simplify, and we end up with this equation 14. Then we take equation 1. Equation 1, we just make a substitution of our equation 13. And that's what we're going to have. So now we look at equation 14 and 13. And we're going to start looking at the coefficients of my powers of y. So we look at from equation 14, we have here, this is from y to the power 1. And that gives us we integrate, so this is my y to the power 1 from equation 14. The 3 is irrelevant. So we then have, this is what we had. We integrate once, we get a prime is equal to c1, whereas c sub 1 is just a constant. And then we integrate again, and that gives us a definition of a of x in terms of some constants c1, c sub 1, and c sub 2. The second part of equation 14 is where I have just y to the power 0. But there's not enough information to do anything with my c prime and my b double prime. I can't do anything with them. Not yet. So we write it out and we number it, equation 17. We just wait. So then we go back to equation 15. Now in equation 15, I don't need to worry about my a triple prime because I've already defined a of x. So we're going to move on. We're going to go here. Oops. We're going to go here and we're going to look at c double prime. We integrate twice, similarly to what happened in to find a of x. And that gives us c of x. Okay, so from c of x, we can now substitute into equation 17 and get a definition of b of x. So notice I have a of x now defined in terms of some constants. We have c of x defined, and now we have b of x defined. So d of x is also going to be determined the same way that we have done with a of x. So we're going to just integrate twice. It is important just to keep track of when you have so many constants coming up and we're naming them just c sub 1, sub 2, sub 3, just to make sure you don't accidentally reuse a number. And I am actually just going to go straight to here where you will have so C7. And that now gives us the final definition of the last function that we needed. And we can take these now and we can substitute into our definitions of xi and eta. So I'm just going to put again what we had for xi. So we had a of x times y plus b of x. So now if we make our substitution, so we need to sub in a of x, which was our equation 16. And b of x, which was our equation 20. And we make that full substitution. And we will end up with So that is our definition of xi. And then we apply the same rules or the same logic to then get eta. So here, this is what we had. And in here, we need to substitute so we need A prime. And we need to substitute C and D. So 19, 21. And so what we're going to get then after we do those substitutions okay, so those are my infinitesimals, xi and eta. So from here, to get our symmetries, we literally just look at look at my constants. So if you think of like each constant will count as a symmetry. And so we kind of gather those terms. So what we're going to get so if I look, C sub 1, right? So if you remember, that's what it's going to look like, right? So we have, see if I can make this. There. Okay. So we're going to have that's the first symmetry, second symmetry. Now, depending on how you've numbered your constants and depending on which ones you found first, that's going to change like whether you have like, C sub 1 and C sub 2. But in the end, all your symmetries will match up. So even if you have them numbered differently, you will still have all of them there, if that makes any sense. Okay, so x2, we have just I don't really want to put an equal sign. I just want to put a colon. And then we have Okay, and those are our symmetries.